Piecewise functions. The graph of the function f is shown. The graph is composed of a sloped segment connecting two horizontal rays. How might you write a formula or rule to describe the graph? Discuss. The task of finding a formula is actually 3 problems in one. The ray to the left has a formula, the segment in the middle has a formula, as does the ray to the right. Let's build a rule to describe the graph. Find formulas for the function piece by piece. Identify domain restrictions for each piece. For piece 1, we have that f of x equals -3 if x is less than or equal to -2. For the middle piece, we have that f of x equals 2x plus 1 if x is between -2 to 1. And for piece 3, we have f of x equals 3 if x is greater than 1. We write 3 formulas, one for each piece, and then identify the domain restriction for each. We put it all together in one package like this. This is an example of a piecewise defined rule. As we have found, a piecewise function is a function that contains at least 2 equations or pieces, where each equation or piece is defined in different parts of the domain. So here, this piecewise function contains 3 equations or pieces. And there we go. There's our piecewise rule. There are times when modeling a function with 2 or more rules is required. Here's an example of a parking fee schedule. Rule 1, minimum $10 for the first 5 hours. Rule 2, add $2 for each additional hour. Rule 3, maximum $26 a day. So once we hit 26, we just draw a flat line for the third piece. Note, int x is the greatest integer function, sometimes called the step function. Input a real number and its output is the greatest integer less than or equal to x. For example, int 2 equals 2, int 4.99 equals 4, int -2.1 equals -3. To evaluate a piecewise defined function f at x equals a, we are looking for the value f of a. Since a piecewise function has more than one rule, we need to be careful to pick the rule that applies to a particular argument x equals a. Alright, so here we're going to evaluate f of -3. So that means x is -3. So remember, if x is less than 1, we're going to go with this rule. So x is less than 1, it's -3. So we'll plug in our x, -3 minus 2, and that gives us -5, absolute value, +5. All right, so if x is greater or equal to 1, we follow this rule. 5 is greater than 1, so we're going to plug 5 into this rule here. 5 squared plus 3 equals 28. All right, f of 1. So if x equals 1, we're going with this rule. So we have 1 squared plus 3, which equals 4. Finally, f of -10, we're going with this rule since x is less than 1. So the absolute value of -10 minus 2 gives us +12. And here are all of our answers. To evaluate a piecewise defined function h at x equals a, we are looking for the value h of a. Since a piecewise function has more than one rule, we need to be careful to pick the rule that applies to a particular argument a. Alright, so we're going to do absolute value of x plus 1 if x is rational, and x squared plus 1 if x is irrational. -3. That means x is rational. -3 is a rational number. Therefore, we have absolute value of -3 plus 1. -3 plus 1 is -2. Absolute values makes that 2. H of pi. Pi is irrational. So we have pi squared plus 1. H of the square root of 2. Square root of 2 is also irrational. So that becomes the square root of 2 squared plus 1. That is 2 plus 1 is 3. h of 18. 18 is rational, so that's the absolute value of 18 plus 1, which is 19. All of our answers are correct. This is a piecewise defined function. Here's the rule. It's 10 if t is between 0 and 5. It's 12 plus 2 int t minus 5 if t is greater or equal to 5 and less than 12. And it's 26 if t is greater or equal to 12 or less than or equal to 24, where p is the parking fee and t is the time in hours. So we're going to evaluate at 3 different t values. When t equals 3.5, that's between 0 and 5, the answer is 10. So this equals 10. An even easier way to do it is just to look at the graph. So here we have a t-value of 9.1. So we'll go down here and we see 9.1 is right there. We go up and we see that we're at 20. All right, and then for p of 20, we can go over to 20, go up and see that we're at 26. And you could also look here instead. 20 has a t-value that's between 12 and 24, and the answer is 26. All of our answers are correct. Let C be the cost in dollars of shipping a package on Staten Island based on weight in kilograms. Here is our rule. Evaluate C of 2.7. All right, so 2.7 is between 0 and 4, so that will be 8. And we can confirm that by looking at 2.7, which is around here, and yes, this is 8. All right, 6.4 is going to be 5. 6.4 is somewhere in here. Go up and we see that we're at 20. Finally, 12.3, we're going to go up and see that we are at 35. All of our answers are correct.